Alright, boys and girls, Mr. Trutna here. I'm back. It's been a little bit of a hiatus since I last made a video. However, this right here is Math 2. We're at Clovis High School, Unit 5, Worksheet 2, and we're talking about properties of parallelograms. So, as they say in Mongolia, let's get the road on the show and get this going. Numbers 1 through 5 you were assigned to do. So let's go ahead and go over these right here. Let me zoom it in ever so slightly, see if you can see the problem just a little bit better. Alright, so the given figures are all parallelograms. So every figure that we see in numbers 1 through 5, we're going to assume that they are parallelograms. We're going to solve for the variable or the variables in each diagram. Then we're going to state the property of parallelograms that allowed you to solve for the variable. Okay, so in number 1, you will notice that we have this angle right here. The upper left angle is marked as x. The bottom left angle is marked as 51 degrees, and these two angles are consecutive angles. So the property of a parallelogram says if angles are consecutive angles, it means that when you add them together, they are supplementary, which means that they add together to make 180. So the equation that I'm going to use to solve for x is x plus 51 equals 180, and then I'm going to subtract 51 from both sides of the equation. To solve, those 51s would cancel out, and we would get, or you would get, or I would get, x is equal to 129. So that's the answer. X is equal to 129 degrees. What property did I use? The property that I used was that consecutive angles are supplementary. So when you have a parallelogram, consecutive angles are supplementary. Alright, so that would be the answer to number 1. Moving on to number 2. So number 2, you notice we have a parallelogram, and I'll move this up so you can see it. There we go. But there's no information marked. So we need to mark the information that's given to us. So side D to G is represented by 2x plus 2. I'll write that in. Kind of put a check there. Side D to E is represented by 3x plus 1. So I'll write that in here. Side E to F is represented by 3x minus 3. Alright, I'll put a check there, so I put it into my diagram. And side G to F is represented by 2x plus 6. So I will put that check by it. Okay, so what we're going to do is, and then we want to solve for x. Now, in this problem, if you're really paying attention, you notice they gave us actually more information than we actually need. Okay, so what do we know? So we're talking about the sides. So remember, if a shape is a parallelogram, we know that the opposite sides, for instance, side DE is going to be equal or congruent to side GF. So we know that side DE is congruent to side GF. So therefore, if I wanted to solve for x, the equation that I could generate would be DE, which is 3x plus 1, is equal to side GF, which is represented by 2x plus 6. Okay, so I didn't really need the 2x plus 2 and the 3x minus 3 to solve this equation. Now, ironically, and I'm not going to solve it both ways, but you could have said that 3x minus 3 side, which is side EF, is going to be congruent to, and so that's going to be equal to the 2x plus 2 side, which is side DG. Okay, so either one of those equations would get you the correct answer to x. So which one you choose to use, you don't have to use both. There's only one x, so I'll solve this one. Okay, so I'm going to subtract 1 from each side of the equation, and then at the same time, I'm going to subtract 2 x's from both sides of the equation. In mathematical terms, when I lived in Texas, if I lived in Texas, I never did, but if I did, we would call that the Texas two-step to solve algebraic equations. Why? Because I literally did 2 steps in 1 step there. Okay, so what am I left with after we cancel out? What cancels out? 3x minus 2x, that's x. Bring down the equal sign. Positive 6 minus 1 is 5. So x is equal to 5. What property did I use? I used the property about parallelograms. It said if a shape is a parallelogram, then the opposite sides are congruent. Okay, and so that would be the property. All right, I'm going to use the congruent symbol instead of write out the word. Hopefully you're okay with that. And if you're not, make your own video and write out the word congruent there. All right, number 3. So when we go to number 3, notice we're solving for the variable a, and a is in the expression 3a minus 5 in degrees, so this is an angle, so that's representing this angle right here. Okay, and then we know this angle down here is 40 degrees. So what type of angles are these two right here? Well, these are opposite angles. And remember that opposite angles are congruent. So the expression that or the equation that I'm going to make to solve for a would be the 3a minus 5 is equal to 40. Solving this out, I would add 5 to both sides. That would cancel out the 5's, and my new equation would be 3a is equal to 45. Dividing both sides by 3, we get a is equal to 15. So there's my answer for the variable a. Now the property that I used was that opposite angles are congruent. So if a shape is a parallelogram, that means that the opposite angles are congruent. Okay? And once again, I'm going to use the congruent symbol. There, all right? Okay, number 4. Now, number 4, we have an x and we have a y. So we're going to have to create 2 equations here. So if you notice, when we're talking about number 4, we have side AB, which is represented by 3x minus 5. I know that the opposite side, if a shape is a parallelogram, and this is, I know the opposite sides are congruent. So that means that side AB is congruent to side DC. Okay, so that means based on that, I could generate the equation AB is 3x minus 5 is equal to side DC is 2x plus 2. So that's the equation that I could generate in order for me to solve for the variable x. So let's go ahead and solve it. And once again, I'm going to do the old Texas 2-step here. So I'm going to subtract 2 x's from both sides. Okay, so that would cancel out those 2 x's, but then I'm going to add 5 to both sides. I'm just doing 2 steps in one. That would cancel out those 5's. Now let's write what we have left. We have 3x minus 2x, that's x. You bring down the equal sign, positive 2 plus 5 is 7. So awesome, x is 7. All right, now we got to solve for y. All right, well, if you notice, the 2y minus 6 is the representation of side DA, and the y plus 3 over here is the representation of the side CB. And once again, we know that if a shape is a parallelogram, the opposite sides are congruent. So that means that side AD is going to be congruent to side BC. Okay, so that would allow me to generate the equation 2y minus 6 is equal to y plus 3. And then I would solve this equation out in order to get my variable y. Okay, so I'm going to subtract y from both sides of the equation. I'll do this one without doing the Texas 2-step. The y's would cancel out. 2y minus y is y. Bring down the minus 6. Bring down the equal sign. Bring down the 3. You don't have to write plus 3. It's implied that it's positive 3. Add 6 to both sides. That would cancel out the 6's. Y is equal to 9. Okay, and the property that I used was, once again, the opposite. If a shape is a parallelogram, opposite sides are congruent. Okay, so there we go. So that would be how you go about solving number 4. So if you notice in number 4, they drew, whoever made this problem drew in the diagonals, and the diagonals were there just to try to mess you up in number 4. They call that to distract you. They had nothing to do with solving for x or solving for y. Okay, number 5 though, if you notice, we have the diagonals, and the diagonals actually have values in them. All right, so what do we know about the diagonals of a parallelogram? So remember, they bisect each other. So that means that A to that point right there, the point of intersection, which is 11, is going to be equal to C to the point of intersection. So an equation that I could use to solve for x would be 2x plus 5 is equal to 11. Okay, so I'm going to solve that out. Subtract 5 from both sides of the equation. 2x, the 5's will cancel out, is equal to 6. Dividing both sides by 2, I get that x is equal to 3. Okay, so now what you want to do is, the next part is you want to solve for y. Well, I now know that x is 3, so that means every time I see an x, I can substitute a 3 in its place. And if you notice, that would make this part of the problem 2 times 3 plus 4, that's 6 plus 4, so this part is 10 right there. Okay, now that part is b to the point of intersection, and we know that that's going to be equal to d to the point of intersection, which is y plus 4. So now to solve for y, I could say y plus 4 is equal to 10. Once again, I got 10 by substituting in 3 for x. Subtracting 4 from both sides, I get y is equal to 6. Hopefully that makes sense. So what property did I use that allowed me to solve for x and y? Well, the property that I used was, if a shape is a parallelogram, the diagonals bisect each other. Okay, there we go. The property is the diagonals bisect each other when the shape is a parallelogram. All right, okay, turning it over. You skipped 6 through 11, so let's pick it up at 12. You were supposed to do 12 through 15. So in number 12, or 12 through 15, the instructions say, for what values of x and y must each figure be a parallelogram? So what we're going to do is, we are going to assume that the shape is a parallelogram, and then we're going to apply the properties of a parallelogram to figure out what does x have to be, what does y have to be. Okay, so let's solve for x first. So notice we have this angle right here, which has the variable x in it, and then we have this angle down here, which is represented, but it has the variable x, 5x minus 180. So we want to compare these two angles. So what type of angles are those two angles? They are consecutive angles. Okay, so what's the rule about consecutive angles? Remember, consecutive angles are supplementary. So that means to solve for x, I would go x plus the other angle, 5x minus 180. It's consecutive angle, and that's going to equal 180. Okay, that's the equation I would generate to solve for x. Solving this out, x plus 5x is 6x. I'm going to add 180 to both sides of the equation. So 6x is equal to 360, and then I'm going to divide both sides by 6, so x is going to be equal to 60. So there's my answer for x in number 12. So if x is 60, this shape has to be a parallelogram. That's what we're saying. Okay, and also we need to do the same concept for y. Well, let's solve for y. Notice we have this angle right here, which is represented by 2y. We have this angle right here, which is represented by 4y, and once again, those two angles are consecutive angles. So therefore, the equation I would generate to solve for y would be 4y plus 2y is equal to 180, okay? If a shape is a parallelogram, the consecutive angles are supplementary. Combining these together, I get 6y equals 180. Divide both sides by 6, y is going to be equal to 30. There, okay? Number 13, moving on. All right, so now we're dealing in number 13, and we're solving for x, and we're solving for y, all right? And we're talking about sides of a shape. So we have the top side, which is represented by 3x plus 5. We have its opposite side, which is represented by 4x. So opposite sides are equal or congruent. So the equation that I would generate to solve for x would be, I don't know if it's better, by the way, would be 4x is equal to 3x plus 5. Okay, I don't know if it's better for you to see this. I have a little light sensor on my camera. I don't know if it's better with or without it. It's on right now. The sensor, the light sensor. It's off right now. That looks, whoa. Now all the lights are off in the classroom. Now let's turn the light sensor. Oh, that's pretty good. All right, so we'll do that. So literally, my classroom is dark right now. See? Can't tell, but there's my classroom. It's dark. There's the door right there. Okay, but the light sensor is on, which helps you see the piece of paper. All right, let's solve for x. So I'm going to subtract 3x's from both sides of the equation. 3x's would cancel out. 4x minus 3x is x. That's equal to 5. So x would be equal to 5. Okay, now let's do the same concept for y. So notice, this side is represented by y plus 3. the opposite side is represented by 2y minus 1. So the opposite sides, if a shape is a parallelogram, the opposite sides are equal. Therefore, the 2y minus 1 side would have to be equal to the y plus 3 side. And I would solve this to find y. Subtract y from both sides of the equation. I'm going to do 2 steps in one. I'm going to add 1. Cancel out the y's, cancel out the 1's. 2y minus y is y. That's equal to positive 3 plus 1, which is 4. All right, so in number 13, x is 5, y is 4. Moving on, number 14. Now in number 14, what are we dealing with in the problem? Well, we're dealing with diagonals. All right, so remember, the rule is if a shape is a parallelogram, and we're assuming the problem is a parallelogram, that means the diagonals bisect each other. So that means each diagonal is cut into 2 equal parts. So that means that this part, 2x plus 14, is going to be equal to this part, 5x minus 4. So the equation that I would generate to solve for x would be 5x minus 4 equals 2x plus 14. And then I would use my algebraic skills, good or bad, you still have to use them, in order to solve for x. Okay, we would subtract 2 x's from both sides of the equation. That would cancel out the 2 x's. That would make my new equation 3x minus 4 is equal to 14. My next step would be to add 4 to both sides of the equation. That would cancel out the 4's. That would make my new equation 3x is equal to 18. And then my last step would be to divide both sides by 3. Therefore, x is equal to 6. Okay, now we want to find y. All right, well, if you notice, we're still going to use the property of diagonals. So that means that this part of that shorter diagonal, which is 2y, is going to be equal to the other part of the shorter diagonal, which is x. So we get 2y is equal to x. We just figured out x was 6. So we're going to substitute 6 in the place of x. Dividing both sides by 2, we determine that y is equal to 3. Moving on, last problem that you were assigned, number 15 here. Okay, so we have a parallelogram again. And now we're dealing with the sides of the parallelogram. So we have the top side, which is represented by 4x plus 20. Its opposite side is represented by x plus 26. If a shape is a parallelogram, then the opposite sides are equal. Therefore, the equation that I'm going to generate in order to solve for x would be 4x plus 20 equals x plus 26. Okay, I'm going to solve this using algebra. And once again, whether or not your algebra skills are good or bad, you still have to be able to solve this problem. So we're going to subtract x from both sides. 4x minus x is 3x. We bring down the plus 20. We bring down the equal sign. We bring down the positive 26. Next step would be to subtract 20 from both sides of the equation. That would cancel out the 20's, which would make my new equation 3x, bring down the equal sign, 26 minus 20 is 6, and then your last step in solving for x would be to divide by 3. Therefore, x is equal to 2. So there's x in number 15. Now I'm going to solve for y. Okay, so if you notice, this side is represented by 7y. The side opposite of that is represented by 6x plus 9. The opposite sides are equal, therefore 7y is going to be equal to 6x plus 9. Okay, now I just found out that x was 2, so I'm going to substitute a 2 in right there. So this becomes 6 times 2, which is 12. 12 plus 9 is 21. So my equation becomes 7y equals 21. I divide both sides by 7. Therefore, y is equal to 3. Okay, so there's Unit 5, Worksheet 2, numbers 1 through 5, and 12 through 15. Okay, if you still don't understand this and you've watched the video, then come to class. Freely ask questions. All right? ABC, always be cool.